This is Lab 1 for Physics 2212 charge tapes. So the purpose of this lab is to observe and calculate the amount of charge between two charged pieces of tape and calculate the ratio between atoms and electrons in them. So for some models and fundamental physics principles, we need Newton's second law, which is the momentum principle. We're going to analyze the object's motion and finding the force. We also need the gravitational force, which is minus mg in the j hat direction, and the electric force, which is the constant k, charge 1 times charge 2, and the distance squared over the distance squared. And then we're going to find the charge of one of the tapes and then use the number of electrons, this q equals ne, to find the number of electrons and then calculate the proportion. So some important assumptions: we're assuming that the tape is acting as a point charge, we're ignoring air resistance, and then both tapes are going to have the same amount of charge and being evenly distributed between their bodies. So this is a preview of the results. This is the computational model and some of the values right here. I'm going to talk more about this later. So the system is the bottom tape and the surroundings are going to be the top tape and the earth. So this is how the experiment was set up. First we're going to tape two tapes, creating a charged one, and then we're going to make a bridge-like structure with the tape that's charged, and then get another charged tape, which is tape A, close to the bridge, and it's going to repel the other from its original position, creating like a gap, and then we're going to calculate the distance between them. So these are the initial conditions. This is the tape mass, the length and width, and we have calculated the surface area, which is 0.004 meters squared. The distance we got was 0.02 meters, and then we calculated the mass 0.0002 kilograms based on the given density. This is the other part of the glow script code, calculating the gravitational force, the electric force, the charges, the number of electrons, and then the number of atoms, and then their ratio divided to both of them. And these are the results, same as before. We got the gravitational force on the top tape, and the electric force on it, the charge of the tape, and the number of the deficient electrons, and the number of atoms, and then dividing one by another, we get the ratio of 1.458 elevated to 10 to the power of -7. And we got these results based on the equations we've showed before. Some possible errors are human errors, for example, when calculating the length of the tape, some rounding errors, and the bottom and top tape not being exactly parallel, which could affect the calculated distance between them. So some discussion: what if the electrons had a positive charge and the protons had a negative charge? What would change about the observations? And nothing would actually change, because the tapes would still have the same charge sign, which would make them repel each other, and the signs in the equation would also be the same if you switch positive with negative and negative with positive. And then why is it important to handle the charged tapes as little as possible? And what happens when the charged tapes comes into contact with your hands or other objects? So when it comes into contact with other things, there is transfer of electrons between them, and this is important to avoid, because the movement of electrons from one body to another would alter the values, the number of electrons calculated with the formulas. So it is very important that we handle it as little as possible to avoid as much as possible the transfer of electrons between the hands and the tape.